Okay, this video is about kinetic energy and potential energy. So there are some slides that I have you can take a look at or always review back to. But when we take a look at energy, energy is how much work something can do, and it's labeled in joules. And if we weren't doing distance learning, we would also study work, and work is labeled in joules. And a lot of times, energy is defined as the ability to do work. So energy is kind of like how much work can be done. And they become kind of one of the same things. But for the rest of the year, we're going to be taking a look at two different types of energy. The first one we're going to talk about is potential energy. And potential energy is stored energy. It is one of our storage. And for the most part, it depends upon two things. One is the weight, which is mass and gravity. Those are together, and the height. Um, so when we take a look at it, we have the weight and we have the height. And once again, I'm saying weight because weight is mass times gravity. So looking at potential energy, the higher up something is, the more potential energy it has. The more weight an object has, the more potential energy it has. This is where if you were in class, I would talk about my potential energy as compared to your potential energy and how I have a whole lot more potential energy because I have a whole lot more weight, even though we're at the same height. So if we take a look at the formula for potential energy is the mass times gravity. Mass is in kilograms. Gravity is in the acceleration due to gravity is 9.8 meters per second. Or a lot of times this will be weight, which is in newtons. And this, I do believe, I feel that if you can understand the labels, that is going to help you a lot. And the height is always going to be in meters, okay, for us in ninth grade. So when we take a look at a math problem, we have our example one is if your egg drop vehicle has a mass of 2 kilograms, how much potential energy does it hold at a height of 10 meters? Well, potential energy, the formula for potential energy is the mass times gravity times the height. And in this case, we know the mass is 2 kilograms and our gravitational pull is 9.8 meters per second, and we have a height of 10 meters. So to do the work, we take 2 times our 9.8 times our 10, and when we multiply that out, we get 196 joules. So energy is labeled in joules. So potential energy takes a look at the weight or mass times gravity and the height. If we take a look at the other type of energy that we're going to finish the year out with, it is kinetic energy. And kinetic energy depends upon mass and velocity. Once again, velocity is speed with direction. So when we take a look at it, which has more kinetic energy, a regular car or a race car? Well, the race car has more kinetic energy because it has a higher velocity. And that is taking into account that they probably have the same mass. So we have a problem here. Which would hurt you more? Getting hit by a 15-foot wave or a 2-foot wave? With that idea that the waves would probably be traveling at the same speed, but the bigger the wave has more mass, it is going to impact you greater. So the formula for kinetic energy is equal to 1/2 times the mass times the velocity squared, or 1/2 mv/v. It's important that you square the velocity. Very important. And this is the time where, if we're talking about it, if we take a look at sports, a lot of times when we take a look at sports and energy, whether we're swinging a baseball bat, a softball bat, a club, or we're taking a look at football and the energy given off by a person, that it is the speed of that object that is twice as important as the mass. So when you take a look at a baseball bat, you want to first of all figure out what is the most massive bat that you can swing the fastest. So it is the velocity that is first. You always want to make sure that you have the most velocity you can with the most mass. So to get up to bat with a big old club and go boom, do you think that the more mass it has, the more power or the more energy? But it is the velocity or the speed of that bat. Okay, so our example here is the bird has a mass of 2 kilograms. It is flying at a speed of 5 meters per second. Find its kinetic energy. So kinetic energy, if we go back to the formula, kinetic energy is equal to 1/2 mv squared. And if we take a look at it, its mass is 5, its velocity is its mass is 2, its velocity is 5. So kinetic energy is equal to 1/2 mv squared. So kinetic energy is equal to 1/2, its mass is 2, its velocity is 5. So if we take 5 squared is 25 times 2 is 50, and if we take a half of that, we get 25 joules. Once again, it's energy, so it's going to be labeled in joules. So I recommend that as you go, you find some place to put the formulas so that you have them at your disposal. And I also recommend that you always have the labels so that you can see what they are labeled in to make it work out for you. So we're going to finish our year on the math portion, and have a great day.